Well, thank you for coming to my presentation. I'm glad to be here. We all know that security has blind spots when it comes to software development. And software engineers have gaps when it comes to security. So oftentimes they look to, businesses look to application security departments or an application security person to fill those gaps and to expose those blind spots. And as application security professionals, we get sent down a hunt for developer training. And this can be very painful, and if you've ever had to do it. And in fact, if you've been in some other talks, you may have seen that this is kind of an underlying theme here at SAINTCON, that our current training isn't really working, especially highlighted in Snow's keynote earlier. Developer training seems to be everywhere, but if you take a look at developer training, really drill down into it, a lot of times it's just relabeled pen tester training or sometimes pen tester lab walkthroughs. And this may not immediately seem like a problem, but there are fundamental differences between how pen testers and software engineers need to approach security. So oftentimes developers aren't even interested in pen tester training because it's not immediately practical for them. And sometimes as security professionals, we have a hard time getting our head wrapped around how training for developers should work if it didn't include pen tester training or some sort of breach training. So how can developers code secure without becoming hackers? Well, the short answer is by promoting fundamental practices that target fundamental security concerns. And I'd like to help give my impressions on why a lot of the current training isn't working, and why the software engineering approach to training is a little bit better when it comes to security training for, obviously, software engineers. Then we'll look at some key points recommended that I would recommend to be in your developer training. And hopefully I can give you enough that when you go back to work that you can at least search for training that can help your developers get there. So who am I and where do I get my insights from? Well, my name is Alton Crossley, and they call me names. That's my Twitter handle. But I'm an application security engineer, and I am a Microsoft Certified Solutions developer, as well as a certified ethical hacker and some other security certifications. I have 20 years development experience and a background in network engineering. So I've made that transition from developer to security, and I've worked security from both sides. So let's talk about the pen tester approach and why I don't think it's quite appropriate for training software developers. So a pen tester may start their test. When they start testing, they start with a cookbook. A lot of times, sometimes they'll even use a DAS tool to get them started because there's a lot of common mistakes that are made in software. And right away, this is a good indicator that the current training methodologies aren't working because it has created a pattern of common vulnerabilities. Then after this stage in a pen test, a pen tester, of course, will go and try and use unconventional methods to use the application in order to get access to data that they shouldn't have access to. And developers, when they look at this practice, they a lot of times relate it directly to quality assurance, QA testing. They kind of see all testing as the same. And you'll see discussions on occasion that security assurance is a subset of QA, or security is a subset of QA. And that it can be true from a developer's perspective. And we know there's a lot of crossover between those two groups. And of course, when there's crossover, you would expect us to have a Venn diagram on the next slide because we're nerds. But what I'd like to do instead is show a diagram from ISO 25010. And what this is it shows how security is a specific subset of software development quality assurance. So this is from a software engineer's perspective. And sometimes if security is our primary focus, we might forget how important these other things are, and that security isn't the only important thing to everyone in software development. But what this, of course, doesn't show are the other practices of security, of application security, especially governance, compliance, incident response, things like that. So there's definitely two sides to this coin. But the takeaway here is often developers don't get credit for security aspects that they're already covering, or even QA is already testing. So if we as security professionals kind of find a way to anchor there and kind of build out to encourage fundamental security practices. And sometimes having QA work together with security can really create a synergy. I hate using that word, but it's kind of a good foundation. Having three pillars is much better, just like a stool needs three legs to stand on its own. So it can really create a lot of useful crossover there if you work together. So let's go back to that unconventional ways of using software that a pen tester does. When a pen tester tries to make software do things that it's not supposed to, and are successful, sometimes they get a great bump. It's very addictive, get a little bump of serotonin. And it might really, that's kind of the addictive part of being a pen tester, right? But sometimes what's overlooked is the way that software engineers may see the same events. A seasoned software engineer is able to create functionality that's reliable, it's consistently reliable, and yet it's flexible enough to operate in multiple circumstances. So, in fact, a developer gets a profound thrill sometimes when they learn that somebody has used their software in an unconventional way. It's like it's a live moment that it really separates the builders from the breakers a lot of times, but it's the same coin, two sides of the same coin. Individual developers learn how to, they have to learn how to guide their own monster, but they also have to work together with the rest of the team under the governance of architecture and the engineering standards that they have. So they have to use a specific way to solve their problems and a specific context for bringing in security. So you might ask the question, is flexible code insecure? Well, flexibility doesn't necessarily make code secure or less secure, but it does make a big difference when it comes to the way that they respond to flaws. So when a vulnerability is pointed out and code needs to be changed, inflexible code will often require a change in another place. So they'll change it in one place, it'll break in another, and it's like juggling sand, just in order to keep baseline functionality. And because of this, maintainable code does become a security concern. And to illustrate this, we'll kind of step aside from code exactly, and we'll talk about circumstance in Pennsylvania, 3 Mile Island. Some of us might be familiar with this. And this quote's taken from a documentary by Kyle Hill. But basically, in the control room at 3 Mile Island, investigators found key indicator lights on the backs of panels, switches out of calibration, and tags covering warning panels, and never fewer than 52 alarms blinking at all times. Over 100 alarms would sound when the reactor started to fail in Pennsylvania, and it was impossible to sort the critical ones from the usual. So the point here is that at one point the reactor was running fine, but when a small thing happened, it took a long time to figure out what it was, and it took even longer to fix it. The lack of transparency that they had internally then caused communication problems, and then it became a public relations nightmare. If you look at some of the documentaries, you come to understand that 3 Mile Island could have been insignificant, but it wasn't. And what we want to take away from this today is that they didn't finish with detail. In software, the control room could be likened to DevOps, from planning through code to operations. And the longer a problem exists, the harder it is to fix. And of course, the more data can be lost, and the more costly it becomes to fix. And so a messy control room, as it were, runs a high risk of failure and eventual breach. And just like with the nuclear meltdown, this can't be taken back. We've seen this time and time again. And I would consider 3 Mile Island as a good example to parallel code with a finish of about level 2, when it should have been code finish of level 5. So what is code finish? I'm talking about software finish levels. And so here, obviously the definition of finish, the manner in which a creation of an item is completed in detail. So it's the craftsmanship. The finish really has nothing to do with anything like agile frameworks or how secure the application is to begin with. Really what it does is it focuses in on the code and how that code is produced. It touches on code readability, code organization, naming conventions, things like solid and dry, and infrastructure as code also plays into this. Unfortunately, it's really common for applications to be of level 3, have a level 3 finish. And the reason I point that out is if you're used to a level 3 finish, you may think of security and quality as something that's very hard to achieve and very expensive, whereas with a level 5 finish, this isn't the case. And a level 5 finish is achieved with organization and teamwork, and some people on the team having very specific skills. And it doesn't take more time to have a level 5 finish, but what it does do is it saves time again in the support of that and responding to flaws. So software finish actually can be as effective as architecture, technical design, and security assurance. And you might ask why? Well, let's take a closer look at this level 5 finish. The reason is because it's well organized and it's clear what's being done. That makes turnaround of flaws much more efficient, and changes can be made with confidence. When they make a change in one place, it's not going to affect another. And when there is a meltdown, the application is transparent to the developers so they can figure out what's going on. And oftentimes it enables solving issues on a systemic level rather than just line by line. And this is because level 5 finish engineers are not line level myopic. Some testing tools, in contrast, might point out, if you've used any SAS or DAST tools that look at code, they'll point out lines that they think are the reason or that might be a risk or that are a reason for a flaw. And sometimes they offer fixes for just that line of code or a solution for the vulnerability, but they usually ignore the architecture and the engineering standards that might be present already. And so when software engineers are told that they should observe these as best practices, it conflicts a lot of times with their other expectations. Level 5 engineers, though, if allowed to their own ways, are able to understand the context that the tool gives them, because that's what it is to them, is context. Then they encourage the team to build a module that's well tested, and then they use that module as a standard. And so that has a much broader positive effect than a line level fix. So we as security professionals should allow them to make this better, sorry, lost my place. We should allow them to have a better solution, more complete solution, a better design. Don't give them a hammer when they should be using a jig. There's a limit to, of course, what influence application security can have over the development process, but making sure that they have the tools and that encouraging foundational practices can really make a difference. And security training should include a lot of these foundational things. So one of the things that I want to point out that's very common, and this plays into the last talk if you were in here, which is really nice. Foundational practice that I see that's common among those doing security development very well is handling merge requests well. Having a standard for merge requests or pull requests, whichever terminology you use, is really important. You can have branching strategies that vary widely, but having a good standard merge request policy is really important. Always require at least another person's sign-off other than the person creating the code. And this is when we're talking about contributor merges, so a single person's changes, so that another person can have eyes on. And make sure that they're using a tool that the merge can be commented on, and then they actually have a exchange of knowledge. And ideally, when this merge request is created, multiple security tools would be kicked off and would also decorate that merge. So you're running SAST and DAST and SCA all within that merge request. So then it can be a part of a discussion and an interchange of knowledge. And this is also where code review scales. So a lot of times we look at code review as a big daunting task of reviewing the whole application. But if we train the more senior developers in security review, then they can take a look at this with an eye to security. And so this merge request is very important. And because the merge request is important and the information in it is important, what can happen sometimes is the tools can be too chatty. They might overwhelm with a lot of useless information, or they may not integrate the way that the developers want to. So the other side of that coin is that as security professionals, we have requirements for reporting and tracking. And tools don't often do both of those well. And so sometimes having separate tools for devs and assurance, security assurance is important and very useful because you can also hand off some of that responsibility to the developers for their scanning so that they can get the information that they want where they need it. And it doesn't, you can give them that freedom and it doesn't affect your outputs that you need. And I'm not the only one that has suggested this in the past. And I'm also not the only one that has suggested this either. Using a framework is really important. I think is one of those things that we can, it comes up often, but it really is useful. A couple of simple frameworks that are easy to implement. The 4-question framework for doing threat modeling is really light and adaptive, so you can just integrate it into agile functions. So different meetings that you have for agile, rituals is the word that they always use. You do it during any sprint ritual. Also having a development team fill out the SAM evaluation can also open, just filling it out once can open their minds to kind of some of the things, the activities that can be done that can move the needle. So that's pretty useful too. But finding a framework and using one is really good. So it may seem obvious to promote developers to security roles, but there are a couple of challenges with this. The first one is a accomplished security or accomplished software engineer is going to be paid more a little bit than a entry-level security position usually pays. So that has to be taken into consideration. And then the other thing is that if they're an experienced software engineer, they've spent a lot of time building, and sometimes switching over to the breaking side really isn't something that they're interested in, or even going from building to testing. So that raises the question, how do you get software engineering experience onto the security side? Well, enter the software engineer in security. Excuse me. So you've heard of the agile role of software engineer and test. This is similar to that. So this is a role where a person still contributes to code, but they're encouraged to spend more time in code review and those merge requests to keep looking at code with security concerns. And also they're encouraged to and enabled to keep up on security happenings, especially as it applies to their current platform that they're developing with. So one important thing here is that they would not bear the whole burden of security and software engineering, but they would be trained to understand and share security best practices. A lot of this, again, is happening through the merge request. So the merge request is all important. So you might be asking yourself, is this a security champion? And the short answer is no. This is a job title and a position. It's not a volunteer role. So if you were in one of the talks earlier about that talked about security champions, this is different. It's more specific. It's more, I feel, more professional and more effective in a lot of cases. Don't get me wrong, security champions programs at some places work really well, but this can even be used to augment that. This is really security embedded. So what are some of the foundational practices, some of those things that software engineers should know to create secure software? Well, as we talked about before, the merge request is very important, and so code review is really important. Doing this in a highly productive manner is very difficult. Being able to give positive feedback without triggering defensive people, without causing people to be defensive, is somewhat of an art form. And understanding like the context of it, so you yourself don't get defensive. But security obviously isn't the only part of this ritual, but identifying vulnerability and then talking about it in security terms is actually really beneficial, because then that informs us as AppSec engineers, so we can understand better what's going on. So that's very useful. Then defensive coding. I think this is something to key in on, because there's lots of defensive coding training out there, and all of it has value when it comes to security. So Wikipedia defines defensive coding as defensive coding is intended to ensure the continuing function of a piece of software under unforeseen circumstances. It focuses on things like code comprehension, code quality, and predictability of code. And it goes to reason that this would also be the basis for things like fail secure, exception handling, and things like unit testing, defense in depth. And so this can be a simple training that could be very beneficial to you at your organization. Input interaction modeling is understanding input data, what it is, how it's being used, and then being deliberate about the implementation of the use. And so we know there's a lot of vulnerabilities that come from that, from just simple input handling. Dependency management, of course, is a huge subject that could be a talk on its own. Most of the public package feeds are full of level 0 finish code, and developers contribute to those feeds not intending to support your medical device or your fintech app. And so developers need to be very cognizant of the dependencies that they're using. They need to know how to pick a library. They need to understand when to build and when it makes sense to fork, because it does sometimes. Implicit requirements are all the unspoken requirements. Sometimes you'll get requirements that require authentication, but they don't say anything about it. And sometimes a requirement also requires the opposite to be true. So understanding those things and just having the language to talk about it is very useful. Logging, of course, can be detrimental and very helpful. So covering that is important. Secrets management, having a way to keep your secrets out of your commit history is very important, especially when you're talking about protecting your supply chain, or you as the supply chain too. Modern auth flows can get pretty complex. Understanding the formats and things is really important to cover. Least privilege and session management along with that. Trust boundaries is something that a lot of developers are able to just ignore, and so we want to make sure that they get that training so they understand when a browser can be trusted and when that trust ends, as well as useful things like HTTP, where headers and cookies come from and go. And then standards and conventions play directly into code comprehension, so they help there. Then secure CI/CD. So having those pipelines secured really depends on the developers a lot, and secrets management too. But having them on board doesn't really take more time. They just need to be cognizant. You may be disappointed too in knowing how many of your developers don't understand the difference between encryption and encoding, because it just never comes up for some of them. So whenever selecting training, a key way to get buy-in from the developers is to include them in the decision. Maybe get a software engineer to actually take the test for you and really dive down into the content, make sure it's spending enough time on the things that make a difference. The majority of the training very definitely shouldn't be spent on any sort of breach training or pen tester training or exploit demonstration. It really should get down to the software engineering tax. There are several major training players out there that have really bad review questions. So that's something that I like to key in on is those review questions, making sure that they're asking about the material instead of just asking questions about quirks in the presentation. So they're trying to make sure that you watched the video or read the document. And a subject matter expert should be able to pass all the questions without even using the content. So here's the big takeaway really is don't spend money or time trying to change the way developers think, trying to make them a hacker. Instead, help them to hone their craftsmanship. Give them the tooling and the training to address the fundamentals to build a foundation for a robust software development lifecycle. And then address security concerns with software engineering tactics. Because a secure software development lifecycle will never outpace the underlying implementation, the underlying process, because the best way is for developers to code secure without becoming hackers. And I will stick around if anyone has questions on the sides of the stage. I'd love to hear any of your comments. Unfortunately, I'm out of time.